So welcome again to my channel, that is eMaths, as we check the second example in Maclaurin series. And we have an example here from a KNEC past paper. We're supposed to solve the function of 1 plus x into their cube roots in Maclaurin as far as the fourth term. Then we set x to be 1 over 8. We determine the cube root of what? The cube root of 9. Now, so again, solution. You can check the solution. So we are supposed to differentiate this function up to the fourth term. Okay, so that is when we talk about the fourth term, remember when you're expanding functions of this term, of this form, sorry, then it means you will expand up to where you shall have x being cubed, or the cubic function. Remember, the value, the power of x starts from 0 going forward. Now, so we have a function f of x, which is 1 plus x, then power third. Then we're supposed to determine f of what? F of 0. So 1 plus 0, 0. 0 to power 1 plus 0 is 1. Then 1 cubed, cube root just gives us 1. 1 to any power is just 1. Now the first derivative. So the first derivative here, drop the power, reduce the power by 1, then differentiate the function inside. Right, together. So as we said, this one is differentiated using the what? Using the chain rule. But I showed you in the previous example that you can do this in a very simple way. Drop the power, okay, then 1 plus x, reduce the power by 1. So what is a third minus 1? A third minus 1 is negative 2 over 3. Then differentiate whatever you have inside here. So what do you have inside here? Is 1 plus x. So when you differentiate this, you'll only differentiate the x. When you differentiate x, you get what? You get 1. So therefore, you can just say, this one just gives us a third, 1 plus x, then negative 2 over 3, because you're multiplying by 1. So therefore, again, first derivative, when you replace a 0, 0 plus 1 is 1, 1 to any power, regardless being a positive or negative, is just 1. Then 1 times a third just gives us what? Gives us a third. We go to the second derivative. Again, so we have this function here. Again, the same procedure. We have a third here. Drop the power, negative 2 over 3. Reduce the power by 1. Reduce the power by 1 gives us negative. So 1 plus x. Reduce this power here by 1. So it is negative. That will be negative 5 over 3. I believe so. Then differentiate the function inside. Get what? Get 1. So now we can multiply. This one is negative 2 over 9, 1 plus x, then negative 5 over 3. Therefore again, f double prime 0 gives us what? 1 plus 0, 1. 1 to any power is 1. 1 times negative 2 over 9 gives us negative 2 over 9. So this one will be the first term, the second, the third. So we are going up to the fourth term. So that means we only differentiate the third times. So x. So we have negative 2 over 9. Okay. Drop the power. So our power is negative 5 over 3. Then 1 plus x. Reduce the power by 1. So this one gives us what? Negative 8 over 3. Then differentiate the function inside. Are we together? So this I can say it's a really short form of doing the chain rule. Are we together? When our functions have powers, it is drop the power, reduce the power by 1, then differentiate whatever you have inside, then you multiply with the function. So in our case here is this. We have our term. This one is a constant. Drop the term, then treat this as a whole term, as one term. Then reduce its power by 1. Then differentiate inside. When you differentiate inside, we will differentiate only the x. When you differentiate the x, it gives you 1. So therefore again, it will give us what? This time this gives us negative 10. Negative gives you positive 10. So 10 over 20, 10 over 27. Then 1 plus x, then negative 8 over 3. So then that one, 3, replace it with a 0. It will be 10 over 27. So that will be your expansion using the Maclaurins. So therefore now, since we have all the terms that we need, now we write the Maclaurin's expansion itself. So we shall have, so it is the first term. So our function is 1 plus x then a third. Okay, we have a third there. So it is our first function here, which is 1 plus the second is a third, then you have x. The third one is negative, so this one becomes negative. Sorry for that. So this one becomes negative. Our value is negative 2 over 9 x squared over 2 factorial, then plus 10 over 27 x cubed over 3 factorial. So this one gives us 1 plus a third of x. Now we have 2 over 9 divided by 2, because 2 factorial is the same as 2. Okay, that will be 2 over what? 2 over it will be 2 over 18. When you simplify that, it becomes 1 over 9. So negative 1 over 9x squared. Then you have that. This one is 10 over 27 divided by what? Divided by 6. Remember, 3 factorial is 6. So what we are saying is, so you have 10 over 27, then you divide by 3 factorial. 3 factorial is the same as 6. So 10 over 27 divided by 6 is the same as 10 over 27 times 1 over 6. That gives you 81.5. So 5 plus 5 over 81x cubed. Therefore, when you expand the first 4 terms, 1, 2, 3, 4, the first 4 terms of the expansion of 1 plus x to power 1 over 3, then it will give us this. Now from this, we now use it to solve the second question. The second question says, setting your x to be 1 over 8, we determine the root of what? We determine the root of 9. So therefore, we are just saying, where you have an x, replace it by 1 over 8 in each and every term here. So therefore, we shall have 1 plus 1 over 8. So we're checking the second question, 2, 1 over 8, then to power a third, okay, equals to 1 plus a third, 1 over 8, minus 1 over 9, 1 over 8 squared, plus 5 over 81, 1 over 8, then cubed. So can we evaluate that and see what that one gives us? Now, what do you get on the right hand side? So you'll get a value of 1.0400. But now remember, when you simplify this, you'll get 9 over 8. 1 plus 1, remember, here we're getting, it's 1 plus 1 over 8. 1 plus 1 over 8 gives us 9 over 8. But remember, we're supposed to get what? The cube root of 9. So in one case or the other, we're supposed to get the root of 9 on this side. So remember, our power applies to every value inside the bracket. So we shall have 9 to power third, 8 to power a third equals to 1.04000. But what is, we want to remain with 8 cubed. What is the cube root of 8? That will be 2. So it will be 9, which is a cube root, equals to 1.400. Now your 8 cubed, cube root of 8 is 2. So we remember, here we have over 2. But you can remove these 2 by multiplying both sides by what? By 2. So you can multiply by 2 this side. Okay, it is over 2, then multiply by 2. Therefore, we are saying that your cube root of 9, so 9 cube root, which is this value here, with the 2 out, we shall have 2, there's a 0 here, okay, it will be 2.08 into 3 significant figures, or 2 decimal places. So your value of this will be this, and you can always confirm this from your calculators. Does the value of the cube root of 9 give you a value which is similar or very near to this particular time? So we majorly say this one is an approximate. It is not the exact value on which one you get in your calculator, but the value itself should be a value very near to this particular term. And that is it for the 2 questions of our Maclaurins. You can check as many as possible. So if you have any questions on a particular paper or on a particular question, you can always let me check it out and I'll help you in solving it. That is it for the Maclaurin series. See you in the next lesson as we check revision in Taylor's series.